SPH Lesson 1, Tutorial 2, page 25. Question 1. How long does it take a radio-controlled car to accelerate from 3.2 meters per second west to 5.8 meters per second west if it experiences an average acceleration of 1.23 meters per second squared west? First of all, identify the information given. The initial velocity is 3.2 meters per second west. Final velocity, 5.8 meters per second west. Average acceleration, 1.23 meters per second squared west. What is required? How long, which is time. The analysis. Change in time is equal to the final velocity minus the initial velocity divided by average acceleration. Substituting in our numbers, we get the solution. Change in time equals 5.8 meters per second squared, or meters per second, minus 3.2 meters per second, divide by 1.23 meters per second squared. 2.6 divided by 1.23 is 2.1 seconds. Now, tutorial 2, number 2. A speedboat experiences an average acceleration of 2.4 meters per second squared. If the boat accelerates for 6.2 seconds and has a final velocity of 17 meters per second west, what was the initial velocity of the speedboat? We are given the final velocity, 17 meters per second west. Average acceleration, 2.4 meters per second squared west. Change in time, 6 seconds. What are we asked to find? The initial velocity. What's the formula we'll use? The initial velocity is equal to average acceleration times change in time minus final velocity. Substitute in. The initial velocity is negative 22.4 meters per second squared times 6 seconds plus 17 meters per second. So the initial velocity is 2.1 meters per second west.